Hello everyone. Today we're going to do exam 3 review. There are 25 questions and I strongly recommend you to do these problems with me. Just you can print out this exam review and then just grab a pen and paper and work with me. So the first question is determine all the critical points for the following function. If you have given a function, to find the critical points you need to find the derivative, and then after that you need to equate that derivative to 0 and solve for x. So basically you're trying to find out the points where the derivative is 0 or undefined. So let's find out the derivative for this function we have given. So the derivative of this function is 2x minus 10 by using the power rule, general power rule. For the critical points for finding the critical points for this one, you need to find the points where the derivative is 0 or undefined. So here you can see that this, if you try to solve this equation, you see that the derivative would be 0 when x is 5, and there is nowhere the function is the derivative is undefined. So the critical point is x equal to 5. Second question, find the extreme values of the following function and where they occur. So you need to find out the extreme value, maximum or minimum. To find out that thing, you always have to find out the critical points. That means you need to find out the first derivative. So in this case the first derivative is 6x minus 5. As you can see that you can use the power rule for x squared, which is 2x, because there is a 3, so 3 times 2 is 6, and then derivative of x is 1, so 5 times 1 is 5, derivative 2 is 0, so you don't have to write anything. So first of all, to find out the critical points, you have to equate the first derivative with 0, and then after that solve for x. In this case it would be 5/6. Now to find out the absolute the extreme values, you need to find out the second derivative. So the first derivative is here, the second derivative is 6, which is always positive. If the second derivative is positive at any critical points, in this case the second derivative is always positive, that means it is also positive at 5/6. That means this function has a minimum value at 5/6. So the one of the answer you have to choose absolute minimum. There are only two answers. The one is 5/6 is this one. So no, x equal to 5/6. This is the one, and this is the one, but there is the maximum, so we just have minimum. So y has minimum at x equal to 5/6. If you really want to find out what is the minimum value, you can just plug x equal to 5/6 in the given function. So y when x is 5/6 is 3 times 5/6 square, 5/6 square minus 5 times 5/6 plus 2, and if you do this maths correctly, that will give you -1/12. So this function has an extreme minimum value because the second derivative is positive, and then minimum value itself is -1/12. So just don't be confused. The absolute minimum value at x equal to 5/6, and then value itself is -1/12. So this is the right option. Absolute minimum value of -1/12 at x equal to 5/6. Let's go to the next problem, problem 3. In this question we need to find out the value of c such that the derivative of this function at that c should be equal to f of b minus f of a over b minus a. Keep in mind, a is -2 and b is 1. So you can first find out the derivative of the function here. So this is problem 3. Derivative of this function is 6x plus 5. You want to find out the c, where you can just replace this x by c, and that derivative of the function at that point c should be fb minus fa. So in this case, fb, which is 1, because b is 1 here, as you can see, this is a and this is b, so b is 1. So the value of the function, find the value of the function at 1, find the value of the function at -2. If you do your math properly, then you can see that f of 1 is 6 and f of -2 is 0. So if you try to compare f of c equal f of b minus f of a over b minus a, just plug the value of this f of c, f prime of c, which is 6 times c plus 5, f of b, which is 6, f of a, which is f of -2 is 0, b minus a, which is 1 minus -2. Don't forget that a is -2. So this is basically 6 over 3, which is 2, which is 6 times c plus 5 is 2. Now our job is to solve for c. 6 times c is, just subtract 5 from both sides, it will give you -3. And if you divide both sides by 6, it will give you -12. Okay, so the answer for problem 3, the value of c where the function, the derivative of the function is equal to this one, is -12. So next problem, the velocity is given, you need to find out the function, distant function, position function. So you are trying to go from derivative to back, so you try to do the antiderivative. So I can do this problem here. So number 4, so the antiderivative of the position function is given 9.8t plus 8, and you want to find out the function itself, so you need to find out the antiderivative, and that is antiderivative of this term, which is 9.8. The antiderivative of t is t square over 2. The antiderivative of 8 is 8 times t, plus you also have to add one constant, because if you try to find the derivative of this function, this constant will be 0. So now this is the general position function, but you can make it specific because you have given the position function at the beginning is 15. So just replace, just put t equal to 0 here. S of 0 is equal to 15. So just plug t equal to 0 here, and it will and use this situation here. So 15 equal this 0, and the leftover would be c. So the value of c is 15. So from this two thing, you can say the position function s of t, which is the function of time, is 9.8 t square over 2. If you divide this 9.8 by 2, it will be 4.9. So instead of writing 9.8, I can write 4.9. T square plus 8t and c is 15. So this is the position function. Okay, that's problem 4. So just the antiderivative going back. Let's go to problem 5. We have given the derivative. We are trying to find out the critical points, which is basically just equate this derivative to 0 and solve for x. and we want to find out where this function is positive, or where the function is increasing, where the function is decreasing. And we can find out that information by looking this derivative, where this derivative is positive, in that interval the function is increasing, where this derivative is negative, on that interval the function is decreasing. Okay, so let's do that here. Problem 5, the derivative is x minus 4, x minus x plus 6, x minus 9. To find out the critical points, you always have to equate this derivative equal to 0 and solve for x. If you do that, on the left side you get x minus 4, x plus 6, x minus 9. And if you try to solve this equation, there are three possibilities, that is negative 4, negative 6, positive 4, negative 6, and positive 9. So these are the three critical points. Now to find out where the function is increasing, decreasing, or decreasing, so what we're supposed to do is we just plot this critical points here on the number line. So negative 6, positive 4, and positive 9. Now you can see that these three critical points will divide this number line into 1, 2, 3, 4 intervals, from negative infinity to negative 6, and then negative 6 to positive 4, 4 to 9, and 9 to infinity. Now to find out where this function is increasing or decreasing, you just have to find out where this derivative is positive or negative. So we're going to just choose the testing point from each of these intervals. So testing points, let me just choose testing points here using different color here. Let's say from this interval. Okay, so from this interval, let's choose from here the testing point is negative 7. You can pick anything, but I'm just picking the simple one. From here I'm going to pick 0. From here I'm going to pick maybe, let's say, 5. From here I'm going to pick, let's say, 10. And I'm going to find out the value of the derivative at negative 7, and the value of the derivative at 0, the value of the derivative at 5, and then value of the derivative at 10. So as you can see that the derivative of the function is it's x minus 4, x minus 4. Just plug x equal to this testing points here. So let me just copy it here. F prime is x minus 4, x plus 6, x minus 9. So if I replace x by negative 7, this term would be negative 7, negative 4 is negative 11, negative 11 times negative 1, because negative 7 plus 6 is negative 1, negative 7, negative 9 is negative 16. So eventually what matters is either this value is positive or negative. So negative times negative is negative, and it's actually 160, 176. So negative 176, so which is negative. The only thing matters is either these values are positive or negative. If the derivative is negative on that interval, that means the function is decreasing. Okay, if the derivative is positive on that interval, the function is increasing. So if I put 0 here, because this will be negative 4 times 6 times negative 9, which is eventually positive. So this is the function is increasing on that interval negative 6 to 4. Here, because of this, the function is decreasing. The function is decreasing on negative infinity to negative 6. So let me just make it a little bit bigger so that I can write here. From here I can say function is because it's a negative, decreasing on the first interval negative infinity to negative 6. Okay, finally if you put x equal to 5 here, as you can see that 5 minus 4 is 1, 5 minus 9 is negative 4, so eventually it will be negative. So that means the function is decreasing on the next interval, which is 4 to 9. And finally if you put 10 minus 9 is 1, 10 minus 4 is positive 6, 10 plus 6 is 16, so all positive number that will tell the function is increasing. So remember, it's only either it's positive or negative. Okay, so now you can see that the function is decreasing here, increasing here, decreasing here, increasing here. So what happens is, if you go to this the number line here, the function is decreasing, and after that point the function start increasing, and after this point the critical point function start decreasing, and after this critical point function start increasing. So this is the nature of the curve you are going to see here, from decreasing to increasing, so that's the minimum value. From increasing to decreasing here, that's the maximum value. One more time, from decreasing to increasing here, that's the minimum value. So at negative 6 and positive 9 we're going to get the minimum value, and at positive 4 we're going to get the maximum value. That's because the derivative is negative here, positive here. So if it goes from negative to positive, it has to be minimum value. So we can summarize that here. We can summarize that information here. Number 5, the function is so let's go back to the question one more time. So now, what are the critical points? The critical points are positive 4, negative 6, positive 9. So critical points are negative 6, positive 4, positive 9. These are the 3 critical points. Okay. And now another question is, the function is increasing on the interval, and if there are more than one interval, just use a comma to separate the answer. So the function is increasing, as we found here. It's increasing on this negative 6 comma 4 and then 9 comma infinity. So negative 6 comma 4, 9 comma infinity. The function is decreasing on negative infinity to negative 6, and another one is 4 to 9. Okay, so the next one is, at what points, if any, does f assume a local maximum value? So as we see here, the local maximum at 4 and minimum at negative 6 and 9. So maximum at 4 and minimum at negative 6 and 9. Okay, so that's the answer for problem 5. Let's go to problem 6. Find the open interval on which the function given here is increasing and decreasing. As you can see that the function starts here at negative 4, it increases up to this point, which is negative 2. So from negative 4 to negative 2 it's increasing, and it starts decreasing up to this point, which is at 0, and from that point 0 to 2 it still increases. So the function is increasing from negative 4 to negative 2 comma, and then again it starts increasing from 0 to 2, and the next part is the function is decreasing. As you can see that it's decreasing from negative 2 to 0, negative 2 to 0 comma, again it's start decreasing at 2, so 2 to 4. Okay, and if you go back to the graph here, you can see that the local maximum, the extreme maximum is at -2. This is local minimum, this is local minimum, and this is extreme minimum, absolute minimum. So this is absolute maximum value, this is local maximum, this is local minimum, and this is extreme minimum. So let's summarize that information. If the function has an absolute maximum, yes, the function has absolute maximum at this is the absolute maximum value at -2, an absolute maximum value at the point x equal to -2, and at local maximum there is a one local maximum, as you can see that it's at 2. So local maximum when x is equal to 2. Absolute minimum, if you go back to the graph, this is absolute minimum value which is at 4. So absolute minimum occurs at when x equal to 4, and the local minimum you can see is when x equal to 0, x equal to 0, x equal to 0. Okay, so let's go to next problem. Problem 7. Identify the inflection point. Inflection point means where the graph changes its nature from concave downward to upward or upward to downward, and that we can find by finding the the second derivative and equating the second derivative with 0. That helps us to find the inflection point. Okay, so first of all, as you can see that this is the graph. If the graph is already given, up to some point the graph is concave down, but some in the middle somewhere it changes its nature from downward to upward. So we are looking for that point. Okay, for that we need to find the second derivative. That's problem 7. Let's go to problem 7. Y equal x cube over 2 minus x square minus 15x. Y prime is 3x square over 2 minus 2x minus 15. Okay, here is the 3, sorry about that. So this is 3 here, so this 3 and this 3 cancel out, and then we can find out the second derivative, which is 2x minus 2, and for finding the inflection point we have to equate the second derivative with 0. Okay, so let's go back here. Choose the correct answer regarding local maxima and minima. We also have to find out the local maximum and minima. As you can see that here at this point this is local minimum, here at this point this is local maximum, so we need to find out that point. And as we did before, to find out the local maximum or minimum, we have to find the critical points. And critical points means the first derivative is equal to 0. If we equate this first derivative with 0, we are going to get x equal 5 and -3. So these are the critical points. Okay, and now to find out the local maximum or local minimum, we just need to find out the second derivative at these critical points. So second derivative at 5 is 5 times 2 is 10 minus 2 is 8, which is positive. That implies the function has local minimum at x equal to 5. So at x equal to 5 the function has local minimum. So that's what we can conclude here. Local minimum. Second derivative at -3, if you plug -3 here, it is -8, and that is negative, so that means it's a local maximum. And for the inflection point where the curve changes the nature, you have to equate second derivative with 0 and solve for x. If you do that, you can find x equal to 1, and you can from here you can say that okay, second derivative is 0 when x is equal to 1. So that means at 1 somewhere here, let's say here x equal to 1, the graph is going to change from concave downward to concave upward. That is the inflection point. So let's try to answer this question here. So the first question is, choose the correct answer regarding local maximum and minimum. So we know that function has local minimum when x equal to 5, but we don't know exactly what is the local minimum. So let's find out that information. Local minimum when x equal to 5, and that is the value of y when x equal to 5. So go back to the value of the function y and plug x equal to 5 there. If you do that, if you put x equal to 5 in the given function, that is 5 cube over 3 minus 5 square minus 15 times 5, just do the math here. It's it's going to be negative 175 over 3. So the function has local minimum when x equal to 5, and that is negative 1753. Similarly, the function has local maximum when x equal to negative 3. We can find out the value of local maximum by plugging x equal to negative 3 in the given function. We do that, negative 3 cube over 3 minus negative 3 square minus 15 times negative 3. If you do this calculation here, it will give you 27. So the function has local maximum at x equal to negative 3, and which is 27. Let's go back here and try to choose the options we have given. Local minimum at 5, which is negative 175. Local minimum at 5, which is negative 175. Local maximum at x equal to negative 3, which is 27. So this is the right option. And now you can see that here, choose the correct answer regarding the concavity. So we know that the curve is the function is concave downward and concave upward, and x equal to 1 is the inflection point, so we have to divide from negative infinity to negative 1, and from negative 1 to positive infinity. That's the boundary. That's inflection point is the boundary. And on this interval you can see that the function is concave downward. So from negative infinity to it's a positive 1 to positive 1 is concave down. So negative infinity to positive 1 is concave down, and from positive infinity to infinity, from positive 1 to infinity is concave up. So that's the option. Okay, let's go to problem 8 one more time. It's a local maximum or minimum value, so you need to find out the critical points. You need to find out the first derivative, you need to find the second derivative. I always try to use the second derivative test for finding the local max, local mean. So let's go back to the function y, which is x cubed minus 3x plus 4. So y prime is so 3x square minus 3, and to find this, the local max, local mean, we can also find the second derivative, which is 6x, and we can find the critical points. For that, we just have to equate the first derivative with 0 and solve for x. And if we do that, we need to solve this equation, which is x equal to plus and minus 1. These are the two critical points. These are the critical points. These points are very, very necessary if you are finding a local maximum or local minimum. And now, after finding the critical points, you have to go back to the second derivative. You have to plug x equal to those critical points. 1, that would be positive 6. That's positive. That means the local minimum. The second derivative at negative 1, which is negative 6. That means the local maximum. Okay. So now we know that at positive 1 the function has local minimum, but we need to find out what is the local minimum, and that we can find out by plugging x equal to positive 1 here. So what we can say, at x equal to 1 we have local minimum, and to find out exact local minimum we just have to put x equal to 1 in a given function, which is 1 cube minus 3 times 1 plus 4, which is actually if you do the math here, local minimum is 2. So you can see from here, choose the correct local extrema. A local minimum is negative at -1. At where is that? At minimum is at 1 and the value is 2. So let's try to find out the local maximum as well. At x equal to -1 we have local maximum, and then value we can find out is, just plug x equal to -1 in the given function here, which is -1 cube, -3 times -1, +4, which is -1, +3, +4, which is 6. So you can see that the local minimum at 1 is 2, and local maximum is at -1 is 6. So this is the option we have. So we need to find out the inflection point. Choose the correct inflection point. For finding the inflection point, we need to find out the second derivative, and as you can see, that second derivative is 6x, and for the inflection point we need to equate the second derivative to 0, and that will give us the inflection point. Okay, so x equal to 0 is inflection point, x equal to 0, but what is the value of the function? The value of the y when x is equal to 0 is 4. So at 0, 4, the function, the graph changes the nature from, the graph changes the concavity. So let's try to choose the option here. There is an inflection point at 0, 4. That's the inflection point. Now let's use this information. Local minimum at -1 and 6, the value is 6. Local maximum. Okay, so this is not the right option. Okay, I made a mistake there, so let me just correct that. The right option for the first part is, if we go back here, as you can see, local minimum at 1, which is the value is 2. Local maximum is at -1, the value is 6. So the first one, local maximum is at -1, the value is 6. Local minimum is at 1, the value is 2. This is the right option. So let's try to find out this information in one of these graphs here. So we know that at -1 there is the maximum, local maximum. So we know for sure that just compare this information here. Look at the graph here. If we look at the graph here, at -1 it gives me local minimum. At -1 it gives me local minimum. So B and D are definitely not the options. So now let's go to A and C. At -1 there is a local maximum 6. Here is a 6. At +1 there is a local minimum at 2. But here it's -1, so the only option we have is C. And then you can also verify your concavity. The inflection point is 0, 4, and if you look at the graph here, this graph is changing the nature at 0, 4, local minimum at 1, 2, local maximum at -1, 6. So that's the option. That's a 6. C is the option, right option for problem 8. Problem 9. Find the dimension of open rectangular box of maximum volume that can be made from a sheet of cardboard 33 inch by 18 inch by cutting congruent squares from corners and folding up the sides. Then find the volume. So this is the application problem. for this derivative optimization problem. So first of all, we need to understand the question. You have to read the question. Find the dimension of the open rectangular box. We need to find the dimension of the rectangular box, which is made up of cardboard of 33 inch by 18 inch. So there is a cardboard. So take up, think about the rectangular paper, 33 inch by 18 inch. So this is 33 inch and this is 18 inch. And now we want to just cut, the same size square from each of these corners. And we don't know what we are, cutting here. So we just assume that this is the X side square. We're cutting this. And now after cutting, this is what we're going to get. This is the board we're going to get. Now what we do is we just flip each side and we make the open open container. So now after cutting, what happens is each side, this side becomes, as you can see that you're cutting this side like X inch from this side and X inch from this side. So all together after cutting, this side will be 33 minus 2x. This side will be 18 minus 2x. And then height of the box, if you flip that box, flip this side, the height becomes X. So what happens is after making the the box, the volume of that box, which is length time width time height, in this case it is 33 minus 2x times 18 minus 2x times x. Okay, and that's because this part from here to here, this is 33 minus 2x. From here to here, this is 18 minus 2x, and if you flip it each side, the height is x. Okay, that's problem 9. Okay, so if you just just multiply this expression to this expression and this, if you just distribute this, this is what you are going to get: 4x cubed minus 102x squared plus 594x. That's the expression you are going to get for the volume. So volume would be the volume of the function. Our goal is to find out the dimension of the open rectangular box to make maximum volume. So this is the function, which is the volume function. We would like to find out the value of x, because dimension means three sides like length, width and height. In this case it's a 33 minus 2x, 18 minus 2x and x itself. If you find the value of x, you will be able to find this side and this side. So we want to make this volume function maximum. We need to find out the critical points where this volume function would be maximum. So we're going to repeat the very same idea. We're going to find out the derivative of this function, which is just find the derivative of this, which is 12x squared minus 204x plus 594. And then again you can find out the second derivative, which is 24x minus 204. And because we are looking for the maximum volume, we need to find the critical points, and for the critical points we need to equate the first derivative with 0, meaning this is equal to 0. And if we try to solve that, we are going to get, this is the quadratic, this will be the quadratic equation. So we need to use quadratic formula and it will give you two critical points, and I'm going to write it down here. That is 17 plus and minus square root of 91 divided by 2. These are two critical points of this. So you can find these points by using the quadratic formula. Then eventually, because this is the critical points, you need to find out where this volume would be maximum at what critical points. And if you try to just plug this critical point at second derivative, So if you plug 17 minus square root of 91 divided by 2, the volumes, the second derivative would be negative. Just calculate that. Just plug x equal to 17 minus square root of 91 divided by 2 in the second derivative we just found here, which is 24x minus 204. That will be negative. That means the volume would be maximum when value of x is 17 minus square root of 91 divided by 2. If you check 17 plus square root of 91 divided by 2, the second derivative would be positive. So from here what we can conclude is the volume v of x is maximum when x equal to 17 minus square root of 91 divided by 2, which is, if you use your calculator, you can see that this is approximately 3.73 inch. So we found the one of the dimension of the rectangular box. Now for the rest of the dimension, we have to find out what is the value of 33 minus 2x, which will be eventually, if you put x equal to this value here, this will be 25.54 inch. And similarly 18 minus 2x is approximately, by using x equal to this value, it will be 10.54 inch. So keep in mind, these are the dimension of that rectangular box we are talking about. So the value of x, value of 33 minus 2x, if you go back to this picture, you can see that 33 minus 2x, 18 minus 2x, and then if you flip this box here, the height would be x. So the dimension would be these three numbers. So we can use this three number here, which is 3.73. So the dimension of the box of maximum volume are 3.73, 3.73, comma, as you can see here, it's 10.54, 25.54, 10.54, 10.54, 25.54, and then from here you have to choose the units, which is inch. They are inch. And then maximum volume, if you want to find out the maximum volume, you have to go back and find out the volume of the function when x is 3.73. As you go back in the volume function, go back here, the v of x is this one. Just plug x equal to 3.73 here, use your calculator, then volume you are going to get approximately that will be, or maybe you can just multiply x times the volume, means it's x times this, or you can put x equal to here, that's the same thing. So eventually it will be approximately it's 1004.08, because it's a volume, it's an inch cube. So this number goes here 1004.8 and then inch cube. Okay, let's go to next problem. Problem 11. The height of an object moving vertically is given by, this is the height function, and then function of time, as you can see here, where t is in second, find object velocity. So this is a position function. To find out the velocity, we just have to find out the derivative. Okay, and we need to answer these questions. The velocity of the object at t equal to 2, find the derivative and put t equal to 2 in that derivative function. So let me just do that. Here it's what is that? Did I skip one question? Yeah, I skipped this one. Problem 10. Problem 10 is what are the dimensions of the lightest open top right circular cylindrical can that will hold a volume of 2197 centimeter cube? So you need to know some of the formula here. This is also optimization problem. So what are the dimensions? If you are talking about this cylinder cylindrical can like this, uh, and this is a right circular cylinder. So this is the can, cylindrical can. So the dimension of the can means it's a radius of this circle, this is the radius, and height of this cylinder. So there are formula you need to know about this cylindrical right circular cylinder. The first one is volume of this cylinder is pi r square h, and then here we're using lightest, meaning we're talking about the weight of this cylinder, which comes from the surface area of this cylinder. So the surface area means, think about a can. The weight of the can comes from, the weight of that surface of that can, the, the material we're using to make that can. The weight comes from the surface area, uh, which is the formula for the surface area is 2 pi r times h plus pi r square. That's called surface area. That also gives you the weight of the cylindrical can. So here in this particular problem we have given the volume, which is 2197, and we need to find out the dimension, which is the value of r and h, which makes this surface area minimum, lightest meaning minimum. So this is what we're going to use here. So the volume, which is volume is 2197, and then we need to find out the value of radius and then height, such that the surface area, which is 2 pi r h plus, as you can go back, 2 pi r h plus pi r square. Okay, so if you go back to the volume formula here, volume is actually pi r square h, which is we have given, that is 2197. So this represents the relation between the height and radius of this, this is the radius and this is the height. This represents the relation between the height and radius. So I'm going to find out the height in terms of radius. So I'm just going to divide both sides by pi r square. So this is the relation between the radius and height. Since we need to find out the minimum value of this surface area, and at this point you can see that the surface area is the function of radius and height both, but we don't know how to find the derivative of this kind of function where the variables are more than one variable. So we need to convert one of the variable into another one. In this case we're going to change this height into radius. So let's go back, let's go here. Surface area is 2 pi r. Instead of height I'm going to just use, that is 2197 pi r square plus pi r square. If I simplify this, I can cancel this pi and this pi, one of the radius and one of the radius. So it is eventually, you can see that if you multiply 2 times this, it is a 4394 divided by r plus pi r square. Now we can see that the surface area is the function of radius. So if we want to find out the minimum value of this function, we need to find out the derivative of this function with respect to radius. So if you find the derivative with respect to r, you are going to see here it's a 4394 divided by r square by using the power rule, and here it is 2 pi r. So since we are looking for the minimum value, we need to find out the critical points. For the critical points, we need to just equate the first derivative with 0 and solve for r. And let's do that. If we do that, it will be the value of r would be, if you equate this thing to 0, it is 2 pi r equal 4394 divided by r square. Just make this thing equal 0 and change the side. And because you are looking for the value of r, I'm going to just multiply both sides by r square. So r cube would be 4394 divided by 2 pi. And if we try to find out the value of r, it will be, just divide this by 2. it will be cube root of 2197 divided by pi, and 2197, yes, and so that is actually the radius is cube root of 2197 is basic, actually it's a 13. Just use a calculator, it's a cube root of pi. So this is your critical number, critical points, critical point, because at this point the first derivative is 0. So now if you try to find out what happens to the second derivative, if you try to find out the second derivative from here, you see that the second derivative of this surface function with respect to radius would be 4394 over r plus 2 pi, and it will be always positive whatever the value of radius you can take here, because radius is always positive. So because second derivative is always positive, the surface area would be always, minimum, and we can say that it is the minimum, local minimum, when the radius is this. So we can say that we use the minimum material to create this can when the radius is cube root 13 over cube root of pi. So the can would be lightest. Can you can see that this can, cylindrical can, is of the lightest, meaning the minimum lightest if the radius is this. The radius is 13 divided by cube root of pi. And what is the what else we need to find? The radius of the can is 13 divided by cube root of pi. And what is the height of the can at this point? At that point, we know that the relation between the height and radius, if you go back here, we found the relation between the height and radius, which is height is 2197 divided by pi r square. If you plug the value of r, this r there, the height will be, after simplification, will be again the same thing, that is 13 divided by cube root of pi. So the height is also 13 divided by cube root of pi. So we need to use the minimum material to create this can, and then this can will be the lightest if the radius we use is 13 divided by cube root of pi, and then also the height is 13 divided by cube root of pi. Okay, that's problem 10. And let's go to problem 11. So I need some extra pages here, so let me just add some extra page. Problem 11. The height of an object moving vertically, this is the height function. We need to find out the velocity. Velocity can be found by finding the derivative of this height function. So this is problem 11. Velocity can be found by finding the derivative of the height function. So if you go back here and try to find out the derivative of this height function is the velocity. So let's say v is the velocity, which is the derivative of this height function, which is negative 32t. Which find the derivative of this one, plus 112. So that's the velocity. But the first question is, what is the velocity after 2 seconds? So the velocity after 2 seconds when t is 2, it is negative 32 times 2 plus 112, and that is 48 feet per second. So 48 is our answer for the velocity. So for the maximum height, again we can do the same thing. We need to find out the critical points, we need to find out the second derivative, and we need to check where the second derivative is, the minimum second derivative is negative. So from here, if we go back here and then find the critical points, meaning the first derivative is 0, the critical point would be 112 divided by 32, which is what is the 112 divided by 32 is 7/2 seconds. So this is critical points. And now because we're trying to find out the maximum height, so for that we need to again find the derivative, the second derivative of this function, which is second derivative, which is negative 32, which is negative always. So the height is maximum at 7/2. So the maximum height is at 7/2 because that's a critical point. And what is the maximum height itself? You need to find out the value of the height function, which is s, when time is 7/2. If you put, here t equals 7/2, the height, the value of s is 280 feet. That's the maximum height. So 280 is your maximum height. And we need to find out the velocity when the height is 0. So for that, first of all, we just equate height equals 0. That means this function negative 16t squared plus 112t plus 84 equals 0. If you solve this for t, that will give you the time when when the height is 0. So if you solve this, this is a quadratic equation. If you try to solve this, this is what you are going to get: half 7 plus square root of 70. So that's the time when the height would be 0. This is quadratic equation, so this will give you two options, but one of the option is negative and there is no negative time, so we're going to use the positive option. So now the last question is, what is the velocity when the height is 0? So the velocity when the height is 0 means you have to use this time. The time t equal half 7 plus square root of 70. The velocity, the value of the velocity, just plug time equal this in the first derivative here, and then find out the velocity, and that will be negative 133.76. So that's the velocity when height is 0, 133.76 feet per second, negative velocity. Okay, let's go to problem 12. This is the Newton's approximation method. Newton's method. You need to use the approximation technique here. For that, you need to remember this formula: xn plus 1 equal to xn, the value of the function at xn, divided by derivative of the function at xn. This is the formula for the Newton's method. And in this problem, we have given a function. We have given two starting points at -1 and then +1. I'm going to do, for the -1, and you are going to repeat the same thing even starting point is +1. And then eventually we need to find out the value of x2 by plugging n equal to 1, n equal to 2 in this formula. Okay, for first of all, the function we have given in this problem is, it's a 3x squared plus x minus 1. This is the function we have given. So this function, the derivative of this function is 6x plus 1. So I'm going to do the starting point x0 equal to -1. I'm going to use this formula. I'm going to put n equal to 0 here, and that will give me the first step, which is x1. x1 is x0 minus the value of the function at x0 over the derivative of the function at x0. So what we need to do is, because x0 is -1, just plug the value, find the value of the function when x is -1, derivative of the function when x is -1, and plug those values here. If you do that here, x0 is -1. The value of the function when x0, when the value is -1, would be it's a +1, and the derivative of the function would be -5. If you use this fact, it will be negative 4/5. That's our x1. But we're looking for the x2, so we have to do this thing one more time. And by using the formula given above, x2 is equal to x1 minus the value of the function at x1 over the derivative of the function at x1. Now I'm going to repeat the same thing here. The function is given, f of x is given. I'm going to replace this x by the x1, which is negative 4/5. And if I do that, eventually, finally, this value would be, it will be negative 73/95, which is in decimal. Yeah, it's a negative 73/95. If you use that value, you can just put that value here. So using the Newton's method, if we start with -1 to solve this equation, our value of x2 would be negative, that's the value you have to put, 73/95. Okay, you can also use the calculator here to use the approximation. If you repeat the same thing with x0 equal to 1, the value of x2 for this part would be 0.447. I'm not going to repeat the same thing here, and it says round to the 4 decimal places, so just use the calculator, divide 73 by 95 and round it to the 4 decimal places. And here also, I missed the one number, so you can also find that number as well. Okay, that's problem 12. Problem 13, this is general antiderivative, so you need to find out the antiderivative of the first term, second term, third term, and you also have to add plus c. So as you can see that, let's go problem 13. This is antiderivative of 5x to the power 14, which is 5 times x to the power 15 over 15. Okay, that's a power rule. And then you also have to do the plus c, but I'm going to add 1 plus c at the end, So again, antiderivative of second term is negative 7x squared over 2, and antiderivative of 2 is 2x. So eventually it is, if you divide this 5, if you just cancel this 5 and 15 from here, it will be x to the power 15 over 3 minus 7x squared divided by 2 plus 2x, and then finally a constant for all of them. So that's the answer. Okay, number 13. So x to the power 15 divided by 3 minus 7x squared plus 2x plus c. Okay, here we need to find out, use a finite sum to estimate the average value of f on the given interval by partitioning the interval into 4 subintervals of equal length and evaluating f at the subinterval midpoints. So what they are saying is, you need to find out the average value of this function on this interval from 1 to 3, and you need to divide this subinterval 1 to 3 into 4 subinterval. So the meaning is, from 1 to 3 there is a 2. If you want to make it 4, you should take 1.5 and 2.5 as well. So there are 4 subintervals now. Now you want to find out the average value of this function by taking the midpoint. So midpoint of each of this subinterval, if you think about the midpoint of each of this subinterval, it's basically, you can see here the midpoint of each of this subinterval, this one which is 1.25, this one which is 1.75, this one which is 2.25, and this one which is 2.75. So you want to find out the value of the function, the average value of the function, by using these midpoints. So first of all, find out the sum of the value of the function at these midpoints. So sum means the value of the function at first midpoint, and then second midpoint, and then third midpoint, finally the fourth midpoint. So these are four different values. We don't want the four different values. We want to find the average. So eventually, after finding the sum, because we use four different subintervals, we're going to divide that sum by 4. So if you do this math, if you find out the value of the function at 1.25, 1.75 by using the function x to the power 4, you can find the value of the function at 1.25, which is okay, so just it is 1.25 to the power 4. So do the same thing for 1.75, 2.25, 2.75, and add them all. Add them all, it will give you 94.640625. Divide that by 4, that will give you 23.66. So the average value of the function f of x, x to the power 4, on this interval, we would like to approximate that average value by dividing this interval into 4 subintervals and using the midpoint of those subintervals. And eventually, we end up with this average value 23.66. 23.66. That's the average. Okay, so now problem 15, we want to evaluate the area of this x plus 10, which is a line from -8 to positive 10. So let's go here. It's problem 15. Problem 15. X plus 10 means the y-intercept is 10, so it passes through 0, 10. So here is a -10. But we would like to find out the area bounded by this line from -8 to positive 10. So what happens here is -8 maybe here to positive 10 maybe here. So we want to find out the area from here to here. Okay, if you look at here, when x is -8, the value of y can be found by plugging x equal to -8 in the given line, which is this line is, we have given this line is x plus 10. So when x is -8, the value of y is 2. And we want to find out the area under this curve from this point to this point. So by looking this here, it's not easy to find the area, but if we divide this region into two parts by drawing this horizontal line from here to here, as you can see that, we can see a rectangle, this rectangle plus a triangle. Okay, so there are two pieces. One is the rectangle, which is, you can see that from -8 to positive 10, this length is 18, and as you can see that the height is 2. So the area of this rectangle is the length, which is from -8 to 10, which is the length is 18, because this is the distance, the length is a distance from -8 to 10. So if you really want to find out the area of this rectangle, it's not so difficult. It's not difficult. It's just a length time the height, which is 18 times 2. So the area is 36. Okay, for the rectangle. And for the triangle, if you look at the triangle here, you can see that from this part to this part, because it's 2, and now if you look at when x is 10, the value of y would be 20 because of this line. So we know this height is 18 because altogether from the bottom part it's 20 and 2 minus is 18. So the height of a triangle is 18. The width of the triangle is again 18. So this part is 18, this part is 18. So the area of the triangle, as you know, that is a half times base times height, which is half times 18 times 18, which is, if you just multiply 18 times 18 and divide it by 2, that is what is that? So that number is 9 times 18, which is 90 plus 162. This is 162. So altogether, the area under this line from -8 to +10 is actually the area of this rectangle plus area of this triangle, which is 36 plus 162, which is 198. And this is a square unit. Okay, so you need to find out the unit, whatever unit we have given, that's the area. Here we don't know what is x, so the area is 198. Okay, we can do this problem by using another formula as well, but I did not use the formula. I just used the this picture here from problem 16 through even including 15, from problem 16 through problem 21. We can use this formula. I'm going to write down the formula here. Integration of f of x of d of x equal, if the antiderivative of f of x is capital of f of x, let's say its general integration is capital of f of x, which is the antiderivative, then the finite integral of this function small f of x would be the value of capital F at b minus the value of capital F at a. So this is the fundamental theorem. So we can find out the definite integral by finding the antiderivative and by finding the difference between the antiderivative from at b minus a. So we're going to use this formula for the problem from 16 to 21. Even you can include problem 15. So let's look at problem 16 here. Evaluate the integration this integration of x. So we know that the integration of x dx is actually it's a x squared divided by 2. So that capital F of x is x squared divided by 2. So now by using this formula, the integration of x dx from 2 to square root of 5 x dx would be the value of capital F at square root of 5 minus the value of capital F at 2. Don't forget that the capital F here in this case is x squared divided by 2, right? So capital F of x is x squared divided by 2. So we just have to find out the value of capital F at square root of 5, which is square root of 5, which is 5 over 2, and the capital F at 2 is 2 squared divided by 2, which is 2. So eventually the value is 5 over 2 minus 2, which is 2.5 minus 2 is 0.5, which is let's plug this value back here. 5 over 2 is 2.5. This is 2.5 minus 2 is 0.5. So the answer for problem 16 is integer or simplified fraction. So that means half, because 0.5 is half. We can use the same thing here for 17. Find the antiderivative of 40 minus 9, which is 40 squared over 2 minus 90, and plug the value 5 and 7 after simplification. So plug 7 first. 2 times 7 is square minus 9 times 7 minus, now plug 5. 2 times 5 is square minus 9 times 5. If you do the simplification, I will let you do the simplification. After the simplification, the answer would be 30. Let's go to problem 18. and this time the integration is from 0 to b 2x squared dx. As we know, the integration for 2x squared is x cubed over 3 from 0 to b, so that is 2 over 3 b cubed minus 0, so the answer is 2 over 3 b cubed. Okay, that's problem 18. Problem 19, we can do exactly the same thing. Find out the integration, which is 12x squared divided by 2 plus 9x log negative 4 and 0. After simplification here, it will be 6 x squared. So if you put 0, it will be 0 minus, and now you have to put negative 4. So 6 times negative 4 squared plus 9 times negative 4. If you do this simplification, it will give you negative 60. So this is your answer, negative 60. Okay, problem 20. Here, before doing the this problem here, we can just simplify this. Cosecant theta is actually, you can keep this 4 outside, 5 pi over 4, 7 pi over 4. Cosecant theta is 1 over sine theta. Cotangent theta is cosine theta over sine theta. So eventually that is cosine theta over sine squared theta d theta. So to solve this problem, I'm going to use the rule of, I'm going to use a substitution here, substitution method. So what I'm going to do is, this is problem 20. I'm going to substitute u equals sine theta. By doing that, the derivative of u would be cosine theta d theta. So eventually what happens is, this integration I'm trying to find here, look at here, it becomes, I'm not going to play with this limit of integration. Let's say just the integration cosine theta over sine squared theta d theta. I'm going to change this notation. So this cosine theta d theta, I can replace it by du, and then the sine squared theta, I can replace it by u squared. If I try to find out the integration of this, it will be, because it's u to the power negative 2, so eventually it would be negative 2 plus 1, so that is negative 1, so it will be 1 over u. So that's the integration, but finally we need to plug back, put back the value of u, which is 1 over sine theta. So for this particular problem, we need to find out the integration of 5 pi over 4. These are the limit of integration, and this function we have given cosine theta over sine squared theta j theta. As we see that the integration, one of the integration for this one is negative 1 over sine theta. So for this formula, the capital F is negative 1 over sine theta. So what we need to do is, we have to just write down negative 1 over sine theta. That's the integration, and we have to put the limit of integration, which is 5 pi over 4 to the 7 pi over 4. So if you just plug this value here, 1 time 1 over sine 7 pi over 4, because of this negative, and the negative from the formula becomes positive 1 over sine pi over 4. Eventually that gives us 0. Just find the value, just make it simplified. So we are going to get 0 for this one. Problem 21. One more time, we can use the integration power rule, and then it's a very similar kind of thing we're doing up to this point. So the integration of this part is 21. So square root of 2 to 1 u to the power 5 over 4 minus 1 over u cubed. Do you remember square root of 2 is greater than 1? So if you want to change the limit of integration and make it 1 to square root of 2, you can put negative sign in front, and that will be u to the power 5 over 4 minus 1 over u cube du. If you want, you can play with this negative sign and make it negative here and positive here, but that's up to you. So now just find out the integration of this part. Integration of u to the power 5 is u to the power 6 over 6, and there is a 4 already, so it will be 24. Integration of 1 over u cube is u to the power negative 3 plus 1, which is negative 1 over u square, and because of this negative already here, it will be positive 1 over u square. And limit of integration are 1 to square root of 2. If you plug the value of u square root of 2 first and then minus this one, eventually you are going to end up with, this will be 8 over 24 plus 1 over 2 minus 1 over 24 minus 1. Okay, so I missed something here. The integration of 1 over u cube is 1 over 2 u square. Okay, so eventually I'm going to get 1 over 2 times 2, which is 4, and if you put 1, that will be 1 over 24 minus 1 over 2. Okay, and if we do the simplification here, we're going to get negative 1 over 24. So that is negative 1 over 24. That's problem 21. Let's go to problem 22. We need at least 2 more pages, I guess. So let's include 2 more pages. And our problem is 22. Before doing the problem 22, I'm going to give you this formula here. For the problem 22, there is a formula: if f of x equal integration of f of t dt from a to x, then according to the fundamental theorem of calculus, the derivative of this integration is actually the function inside the integral, and then replace this variable by the variable you have given here. That's the fundamental theorem. So we're going to use the very same thing here. In our case, the function is y, and we need to find out the derivative of y. 2 plus 3t squared dt. So just compare here. Instead of x, here is a w. Instead of capital F of x, we have y. So the derivative of y with respect to w, here the derivative of capital F with respect to x, is this function. Just replace t by w, which is 2 plus 3w squared. That's it. That's from fundamental theorem, so which is square root of 2 plus 3w squared. Okay, for problem 23, you have to draw a graph to visualize the problem 23 here. It says find the area of the region between the x-axis and then graph. The graph is given from negative 6 to positive 4. So if you try to plot this graph, which is parabola, and it's easy to plot, it's not difficult to plot, and you can find the x-intercept of that parabola, which is at negative 3 and at 0. These are the x-intercept. So if you try to plot the graph of this parabola, this is what you are going to get. And the main thing is, the very important thing is x-intercept, and you can find the x-intercept just by equating this curve with 0 and solving for x. If you rewrite this curve here, y equal negative x squared negative 3x, and if you just factor out negative x, it gives you x minus plus 3. So the x-intercepts are x equal to 0 and x equal to negative 3. So now we want to find out the the total area of the region between x-axis and then graph. So the total area of the region between the x-axis and then graph from -6, let's say this is -6, to +4. So remember, we want to find out the area of this part, area of this part, and area of this part. If you just try to find out the integration from -6 to -3, it will give you the negative answer. So whatever integration you are going to get, you have to make it positive to find the exact area. You understand? So integration of the function, which is y, from -6 to 4 can be split by looking this diagram. We can split it into 1, 2, 3 different cases, which is -6 to -3, and then from -3 to 0, and then finally 0 to 4. Keep in mind the first one and third one integration. If you try to find out the first one and third one, it will be negative because they are below the x-axis, but we are not going to take the negative value because we want to find out the area. Area cannot be negative. So whenever you find the integration of the first part, whatever integration you get, make it, take the absolute value, make it positive. Okay, and for the third one, make it positive. That's how you're going to get the area, this area. Okay, and let me tell you, if you try to find out the integration of this first part by using the same way we were doing from problem 16 to 21, you are going to get -45 over 2. So absolute value of that means it's a positive, and in the middle part you are going to get 9 over 2, and the last part you are going to get -136 over 3. Remember, I did not do this integration because the integration process is very similar to the previous problem. So I believe that now up to this point, now you know how to find the integration of this function from one point to another point. So if you just make this thing positive and just try to add them, if you do this addition thing, you're going to get 217 divided by 3. That's the area between x-axis and this curve from -6 to 4. 217 divided by 3. Okay. For problem 24 and 25, we're going to use the substitution method as it is mentioned in problem 24. Just substitute this lower part by u. So 24 I hope I need 2 more space here. So for problem 24, as you can see that u equals 7 minus r to the power 6. So du is the derivative of 7, which is 0, negative sign. Let me just so negative sign, so this is -6 r to the power 5 dr. So if we substitute this value in the given problem, the problem will be changed into, I can write down that 24 r to the power 5 dr over square root of 7 minus r6. I can change this problem. I just need 6, so I can just make this 24 as a 6 times 4. I can bring that 4 outside, and then there is a negative sign, so there will be -4, and I can replace this -6 times r to the power 5 dr by du. So on the top I'm going to replace it by du. Remember, I just need 6, but here we have 24, so I can split this 24 as a 6 times 4, but I need -6, so I can split this 24 as a -6 times -4. So -4 can be taken outside, and this part would be square root of u. Now I just need to find out the integration of this square root of u. There's a -4. The integration of the square root of u is, this is actually u to the power -2, -half. So it will be u to the power -half plus 1, -half plus 1. And one more time, we need to add constant. Okay, we need to add constant. So if you simplify this, it will be -4. On the top it will be u to the power half, and on the bottom it is again half. And if you flip this half, it will be this 2 and this 4 you have to multiply. So and then finally you need to plug back the value of u. So it will be -8. -8 is from 4 times 2, and u is 7 minus r to the power, let's go back here and check, 7 minus r to the power 6 plus c. So that's the integration using substitution. Okay, finally the last problem, problem 25. One more time, this is I'm going to use the substitution method. I'm going to substitute for 6 plus r to the power 9. So in this problem you can see that 25, let's say u equal 6 plus r to the power 9, then du is 9 times r to the power 8 dr. So for this r to the power 8 times dr, I'm going to replace it by du, and I need 9. So what I'm going to do is, this problem I am going to write it down like 1 over 9, 9 times r to the power 8, 6 plus r to the power 9 to the power cube dr. So I'm just putting 1 over 9 and 9 to make it like 9 times r to the power 8. So 9 times r to the power 8 dr can be replaced by du, and this thing can be replaced by u to the power 3. So eventually, if we find out the integration of u cube, it will be u to the power 4 over 4 and plus constant, and that is, if you multiply 9 and 4, that is 1 over 36. And if you put the value of u back, which is 6 plus r to the power 9, and there is a power 4 and plus c. So that's the answer for the last problem, 1 over 36, 6 plus r to the power 9 power 4 plus c. Okay, if you do not understand something after going over these problems, then feel free to contact me, and all the best.